All right, I think we'll go ahead and get started. Welcome, everyone, to our Simio Solutions series, third episode here. My name is Dan Vasilini. Let me bring my camera up real quick so everyone can see I exist and I'm not a robot. Welcome once again to Simio Solutions series. Let me go through a couple slides here before we get started. All right, great. It's advancing. I'm going to stop my camera so I don't have any. Perfect. All right, so today's session is data-driven / data-generated models. Once again, I introduce myself. My name is Dan Vasilini. I'm the Global VP of Sales. Doing the presenting today, and most of the talking is going to be Liz Miller. You've probably either spoken with her or communicated with her on tech support at some point here within the Simio world. So you can see Liz shaking her head and smiling as her friendly self does. So very quickly, before we get started, a couple of housekeeping items. Just be aware that everyone, we are recording this session for replay purposes. If you'd like to rewatch this session, or if you'd like to refer it on to a friend or a colleague, it will be live, or recorded on the Simio webpage after we're done with this. It usually takes us maybe 8 to 12 hours to get the thing up and running afterwards, but it'll be on the website afterwards. Next thing, just be aware, everyone will be muted on entry coming into today's session. If you'd like to ask a question, there should be a go to webinar box somewhere on your screen. On my screen, it's on the right side, and there is a question or a chat area within that box where you can go in and type your question in. We will try to answer those questions in a timely manner. Our session is scheduled to last 60 minutes today. Liz will probably go for about 40 to 45 minutes. We have intentionally left time at the end for some Q&A. So as you have questions, please feel free to type them in and we will get to them. If there is a question that comes up that is relevant to where Liz is at that point in time, I will break and try to ask the question. But if it's more generic in nature, it can be addressed at the end, we'll address it at the end. Next, just so everyone's aware, we do have our next schedule set here. So 2 weeks from now, we'll be doing periodic statistics. And then we have our sessions set for the end of June all the way through the end of July. So our next 5 sessions, or excuse me, our next 4 sessions are on the calendar there. You can see best practices, modeling labor would be at the end of June, optimizing manufacturing cell, middle of July, and then supply chain decisions with AI at the end of July. So that's our sections as we currently stand. If you have suggestions on something you'd like to see, which I don't know if you're out there and you provided one of these suggestions, we definitely took some of your suggestions to heart and added them to the calendar based upon some things we were receiving. So your suggestions are not going on a deaf ear. So if you do have further suggestions or things you'd like to recommend, please reach out to myself. You can see the email there at the bottom, or you can reach out to anyone that you would see on the call or anyone you know at Simio and say, hey, this is a session I'd love to have for the future. So with that being said, Liz, I will go ahead and turn it over to you, and you are ready to go.
Awesome. Thank you, Dan. All right. Can you confirm that you see my screen?
It's coming.
Awesome.
Yep. Good to go.
Perfect. So let's get into it. As Dan said, my name is Liz Millar. I am a product engineer. I primarily work with our technical support team. I also do other things with the product, such as product planning, testing, documentation. So a little bit of everything here and there. And today's presentation is going to be on data-generated and data-driven modeling. So earlier this year, we had our Simio Sync conference. So that's a conference that Simio puts on, and it's where our users can share their applications and their use cases and the projects they're doing with Simio. And also we have our Simio employees talk about some of our features or cool new things coming up. So if you were able to catch that earlier this year, I did do a presentation on tips and tricks to enhance your model to be data generated or data driven. And that presentation was more geared towards if you had an existing model that you had spent some time on and worked with, and how to change that over to a data-driven modeling approach. So if you're interested in that, we do have information on Simio Sync in general on our website, so you could go and find our Simio Sync section. And we also have our presentations that were from this past earlier this year. So check that out if you're interested. And then, as Dan said, today our presentation will be recorded, and our previous ones are also recorded, and you can find those on our website as well. Okay. Data-driven and data-generated modeling. The first important part of this is your data. So today's presentation, we have that data all pre-made, but we like to kind of just give a little bit of a talk about data. You know, data can be its own project. It's an important project. You want to make sure you have everything prepared for what you are about to go model. So that means, collecting the relevant information. You want to get the data on the system that you want to model, and then you want to clean that. So you want to make sure the values make sense. You don't have missing information. And then the last point here is organize, and that's more for, getting prepared to move this data into Simio. So maybe you have your data now, and you have a lot of data and you have it all in one spreadsheet. And that works for however you're using it. Maybe you just open it, manipulate it a little, look at the summary statistics. But if you're putting it into Simio, that might not make as much sense. You might need to organize it into, these are my objects, or these are like other pieces of information that feed into my objects. So just keep that in mind as you're looking at your data and preparing to start your next Simio modeling project. And then the last point there is just make sure your data is representative of your system. So again, you don't want to grab data that has nothing to do with what you model, or the data that you are grabbing, you want to make sure it's valid. So do these numbers make sense for, my processing time? Things of that nature. So again, just kind of a little warning about your data, making sure it's up to speed before you put it into Simio. So let's jump into what is a data generated approach. So a data generated approach, you're taking your you're taking your data, you're putting it into Simio to build your model. So it's a really quick way to get started for any project. Your data can be read in from an external location, such as an Excel file or a CSV, or from a database. So it's a quick way to get data from your external location into Simio, and then Simio can take that data and build your models, build your objects or build your elements. So it's just a really quick jump start for starting your project. You could do this with smaller scale model, but this really is a approach you might take if you have multiple objects you need to model. So you have a lot of things you need to place out. So it's really going to be a beneficial approach there. So you're making a small model, you can just drag and drop your things into Simio, but when you're making like a large warehouse, which is what we're going to look at today, you might want to data generate that so you can get everything where it needs to go quickly. So as I said, we are doing a warehouse today. We're going to be taking the rack and the lift truck objects and showing kind of data generation for that. And we're going to be showing a warehouse and setting up all of the aisles and rows and that nature. So the lift and the rack are part of our extras library, which should be automatically in your Simio, but if not, you can look and help and kind of get more information on that library. It is a newer library and has some different objects in there. And you could also seek out symbits. So we do have great symbits on our extras library objects and also examples. So all of that's in Simio in the support ribbon. Okay, so when you're data generating, what is the data that you might look for or need? So these are kind of the things that I have planned out for when I'm taking my data and putting it into Simio to create my objects. So when you're creating your objects, you're going to want to have a name. So each of your instances, your object instances in Simio need a unique name so you can reference them. And then you need an object type. So today we're going to be creating racks and also some picking stations. So, I might name my objects picking station 1, picking station 2. But Simio doesn't know what a picking station is. So you need to think about what that object is going to be in Simio. So a picking station might be a server. So I could specify my object type as a server. And then you're going to need a location. So you can have Simio create these objects, but it's not going to know where to place them. So you want to think about how your layout can be given with your data. So a lot of times it's just X and Z coordinates or latitude and longitude, but you're going to want to have those coordinates as part of your data you put in when you're data generating. And then orientation. So which way is this object facing? This is important for our racks that we're going to be making today because, the way your rack is facing is important so you can get the material out of the rack. If your rack is, you want racks facing in the aisle or a different way, that's something you can specify as you generate your objects. And then there's other properties you can think about when you are making your objects that might be useful or specific to that object definition. So there's other things, but these are kind of the main things we think about when we're generating data or generating our objects with data. So with that, let's jump into Simio. And here is my blank model. And first, we're going to talk about getting data into Simio. So you can just type your data into Simio. You could copy and paste your data into Simio. But one of the quickest ways to get data into Simio is to import it. So you can import it with a table data binding. So first, we have to have a table. to put our information into. But then after that, we can create up our data binding. So if we go to content, create binding, and you can see we have options here. So you could import from an MES system, or you could import from a database or Excel. But today we're going to do CSV. So I select CSV, and we see we have some information to fill out here. You don't have to fill it out now. You can fill it out later. You can close it. But we're going to fill out some of this now. So we're going to select the folder where all of our CSV files live. So let me get here really quickly. Okay, so I have my data folder. I have my layout information in this layout folder. So I specify my folder, and then I need to specify the specific file in that folder. So here I have multiple files. These are the objects I want to be creating today, but we're going to start with racks. So I've hooked up my data binding, and then I have to import the data. So I import it, and I could see that Simio made my data table schema for me. So it set up my column names. I could have had these set up before. I could have said, these are the columns I know I want to import, and then I could have just added the data into that. Or if you don't specify that, like we just saw, it'll create your data table schema for you, which is really nifty. So here's all my data. If I go back to my facility, I can see nothing's really happened yet. We have yet to turn on the switch to data generate our objects, but it's very simple. Before we do that though, there's a few things we need to clean up. So Simio is going to do its best to try to make sense of the information you're putting into it, but it doesn't always know the correct type that we've put in. So here we have our rack column. So this is my rack name, and it thinks it's just a string, but I want it to know that it's an object. So I can change this information by going to schema and change type and say, now this is an object. All right, so this is an object reference. But Simio is saying, I don't know what these racks are. You haven't instantiated these racks yet. So that's what we're going to do with our data. So again, selecting this column, we see there's this default value instantiation, and we can auto create. And we have one more thing to fill in, and this is kind of that object type. So you could specify it in Simio, or I could have had a column here that said object type if I was creating different types of objects at this time. But I'm just going to say I am creating a rack. Great. So all the errors are gone because I said I've created these with my data. And I go to my facility and I see they're here, but they are all in this center area because I did not hook up any of my other information. So we do need to do that fairly quickly. So I can go back to my data table, select rack, go to the initial physical characteristics, and I could type a value in here, but this is applied to the whole column. So all of the racks would follow that rule. But I want each rack to be at a unique location. So I can instead say the unique value column here. So I have my X location, my Z location. So if I reference the column instead, so X location and Z location, I can see that we're going to use, each rack is going to use its own value for these two columns. So I can go back to my facility, and now I can see I have something that looks a bit more like a warehouse layout. You know, I have my racks spaced out, but they are facing the wrong way. So this is where the orientation comes into play. And so we can go back to that same location and change the yaw. So the yaw is which way the object is going to be facing. And again, I want to reference the orientation column because some of my racks are going to be facing 180, some are going to be facing 0. And I go back to my facility and I could see that things have gotten lined up a lot better now. Okay. With the rack, we have our input and output nodes, and you can see that those didn't move correctly. So I just want to take a moment and talk about this. With the server object, if we wanted to rotate this, you can hold control and click one of these the handles and rotate and kind of just drag around. And you'll see that the queues and the nodes are moving with the server. That is because if you right click on the node, you can see it has this parent rotation changes location active. And same with the queue. The queue has two different options because it can move in different ways. But if we click on our rack, we can see that we don't have that turned on right now. So we're going to want to turn that on. And I could click on each of these nodes and turn that on, but that's not really going to solve our problem because we want it to be applied to all of our rack objects. So what I'm going to do instead is I'm going to make a custom rack object so that I can make that the default value. So any rack I create from that custom rack object definition will have that rule applied to it. So I'm going to do that by subclassing. So I'm going to open extras library and subclass the rack. And this later as we get into the data-driven part of our presentation. But so this is my new custom rack object, and anything I change here will be, like I could make different defaults and have that carry over. So here I'm going to go to definitions, external, and I see that these are my external nodes that get created when I place my rack. And I can right click and I can set this as the default value for these nodes. So now I see it's enabled. Okay, if I go back to my model though, I see that nothing's really changed. Well, the racks I created were created using this rack definition. I need to change it so it's using my new my rack definition. So we're gonna go to data, and all we have to do is change that object type. So I can go here and I could do, oops, my rack. And it's gonna take a moment because it has a couple hundred racks to do. We'll just let that think for a second. And now I see that my nodes are in a better position and line up with the way that my rack has been oriented. Okay, great. The last thing I want to do is I want to make sure when I auto create my each row in my data is its own instance. So this is a rack instance and this is a rack instance. But when you're auto creating, the rack doesn't automatically know its row. There's a setting you have to turn on that is auto set table reference, and you can change that to true. And so then each instance will recognize its row, and then you could use information in this data table later on.
Hey, Liz,
Yes.
let me ask a question that just popped in here that's very relevant. So, do the CSV files have the field names as the first row, and is a header required?
So the data that I had, I did have my column names in my data table. So maybe I could show that really quickly. Oops, popped up over here. But so yes, so my first row was my column titles. So you could include that in your data. If you don't, there are settings, I think, when you're setting your data binding to exclude the headers or say that there is no headers, and then it'll just come in with unnamed columns. If you don't select that option, it is automatically going to try to use your first row as your table headings. So if I didn't have this row, it would have tried to use this information. So you do want to be a little wary of that and make sure you change that setting if you don't anticipate having column titles in your data. But yeah, those are all settings that you could change.
Okay, perfect. Thank you. I thought that was a relevant question. I hate to break your train of thought, but go ahead.
Yeah, no, great, that's great. Okay, awesome. So continuing on, we have a bunch of other data, objects that I want to create with data. So, we only have our rack sitting here right now, but I really want to have, paths, aisleways, my vehicles, picking stations, and so on. So I can add more tables and should probably name them something relevant, but we're gonna jump to a different model in a second. But the cool thing is that, so I added another table. I can use that same data connector binding, my CSV, and I could say I'm going to use that same one. I already have my folder defined, and I could just select a different file. So here I'm going to say, let's create my notes. And I can import that and do that same thing where I change this to a different column type. You want to try to match your types as best as possible, just because then it helps you out later. You know that this is a node column. These are supposed to be nodes. But this could be an object column, but I'm going to make it a node column and say that these are basic nodes, and I want to auto create them as well. And I'm going to do that same thing where I create them at the X location and the Z location. And I can go to my facility and I can see that I now have a bunch of nodes in between, marking out my aisleways in between the racks. So for the sake of time, I'm going to skip showing how to do the other tables because it's a very similar process. So we're going to jump to another model
All right,
where
hold
I
on.
have, yep.
Hold on. Another question. So in the rack table, is it possible to specify relative locations of input output nodes with respect to each other?
So the rack definition is going to create those nodes for you. So you would have to specify that in the rack definition, or you could have your rack definition not create those nodes and then create different nodes in the data tables. So it'd be a few different ways you could set it up. It would really depend on you changing your rack definition. But let me just jump back into that for a second, actually. So what I'm saying is the rack is creating these nodes here, and you could move them around, um, and then auto create your rack, and it would change. So I'd have to update this for a second. But if you wanted to specify different locations for your input and output, you would probably need to create different nodes. Like they would need to be their own node definition, if that makes sense. So
Okay.
really, really quick. Okay. So we see that now when I recreated them, the nodes have moved locations. So you would specify it in your definition, but you could choose to not create these nodes and then have a table with all your other nodes creating different input and outputs for that.
Perfect.
Clarification on that, yeah, you can email and we can talk about that more later.
Okay. And we also have user participation occurring as well. So someone else is jumping in and answering questions as well in there. So that's great.
Awesome. Okay, perfect. Okay, so we're gonna jump over to a different model where I have auto-created paths, resources, so my forklift and some workers who work at my picking stations or my packing stations, some sinks and the packing stations. So these are all just different pieces, like files of data that I've imported as a table and done those steps that we have just seen. So now we see it's created all of these lovely objects, and it was pretty simple to do. You're just importing, kind of formatting a little bit, making sure everything's hooked up in Simio correctly. All right, awesome. So it's a little busy, so I'm going to turn some of these things off for a second. But we can see this model. If we hit run, it's actually not going to do much of anything yet. We haven't created any entities or hooked up any other pieces of information in that in there. So we're actually going to switch gears and talk about data-driven approach now. So what we just did was data generated, and then we're going to move to a data-driven approach. And these are two different approaches. You can do one without the other. So we could have just had our data generated objects, and we could click on each of these and fill in the information about the racks and whatnot, and click on these servers and fill in the information here, so that would be just data generated, or you could do vice versa and only do data driven. Entirely up to you, but the two approaches work really well hand in hand, because you can quickly input the data that you need for these objects into data tables and then create the data or create the objects. Okay, let's jump back to the presentation for a second. And so moving on to data-driven approach. So data-driven is your data is organized into tables, just as we've been doing. And again, you can type this in or you can import the information as we have done from an external file. And what this is you're using the data in your tables to drive your objects. So you're going to plug in your table references into your objects, and it's going to be a generic table reference, which is really nice because it's repeatable very easily across multiple objects. And then that object is going to go back to the table and say, okay, I know I need to use this table. And then what is the specific detailed information I need? So the data table is holding all your specific details. Your objects have this generic table reference. And this allows your model to be really easy to maintain and update because you have this one central location source of truth. All right, so let's show this with our model we've been working on. So we're going to want to give some information to these shelves, or sorry, to the racks to create these shelves. So with the rack object specifically, we have the ability to create shelves at different levels. So you can specify how many shelves you want, what's the pattern, how many entities are allowed to fit on a shelf, and so on. So by default, that is a pattern option, but we also have this option to do a repeat group. And what the repeat group lets us do is have each of these shelves be unique. So instead of saying I need 3 shelves and they all have to be evenly spaced, here we could say I have shelf 1. So shelf 1 is at height 1 and it can hold, maybe 10 things because it's a bottom shelf. And maybe I want to add a second shelf and that's going to be shelf 2. And I only want to move it up, a little bit. So it'll be half as high, or half, actually, sorry, 1.5. A little bit higher than the first shelf. And it can only hold, 5 things because it's a little bit higher. We want to put less on it or something like that. So the repeat group allows us to create shelves with unique information. So I could go into each of my racks and I could add this, or I could put it into a data table. So my data table holds all of the unique information about my shelves, which is what we're going to do. So let me just delete these. So repeat groups hook up very well into data tables because they're actually very similar structures. And if you ever need to kind of get more information about repeat groups and kind of what that might look like in a table structure, we actually have our data table schemas. So if you add a table, you can go to add a data table from schema, and we have all of our options here, and these are all of our objects and our elements. And so for example, let's go to rack. That's what we're working with. And you'll see for the rack, we could make a parent. So that would be like the rack's properties in a data table, or we could create one of its repeat groups. So here we're just gonna quickly look at shelf configuration. That was the repeat group we were looking at. And if I add that in, it's gonna make a table for me that has the columns that correspond to the properties that were in that repeat group. So if you ever need some assistance in kind of setting up your data table schemas, that's a good way to look at it, and kind of just get an idea of what these columns might be. Okay, I'm actually going to delete these columns because I want my data import to create them for me like we've done before, just because my columns are set up a little bit differently. So here we're going to do the same thing where I just take my same binding, and actually, sorry, and select my file from my shelf configurations, import this, and make a few changes. So I want this, and actually, I want my shelf ID to be a string instead of a number, so I only have numbers here. We're going to change that quickly. And this is where we want to introduce the idea of table relationships. So here I have three shelves per rack. So I have this rack specified, and it's going to have a unique shelf. But this is where we want to relate all of these shelves to the one rack. So I have this column, and I actually want this to be set up as a table relationship. So I'm going to go back to my rack table, and I'm going to say, hey, I have these racks, and I want them to be a key. So I'm going to set this column as a key. So each rack is one key, and it's going to relate back to this shelf table. And this column is going to be a foreign key. So I'm going to change this to a foreign key. And it's going to say, okay, so I know that rack 202 has these three shelves, and it relates back to the same key. So I've used this key 3 times. So if I go back to my rack table, I can now expand this and kind of get this master detail view. So I see that rack 202 relates to these three shelves. So this is kind of where the power of table relationships comes in, where you can say, like, I have this main piece of information and it's going to relate to maybe the subset of information. So in this case, I have this main rack and it's going to relate to these shelves. All right. So going to facility, I can click on my rack and I could say, for my shelf configuration, I would like to use that shelf table we just added in. So my table shelf configuration. Okay, so I right-clicked on the repeat group and I set this reference at the top level, and I could still click into the repeat group and I could see that all of my columns in my data table hooked up to the properties in the repeat group. So we have this all set up. So when this rack goes to create its shelves in the beginning of the run, it's going to look and it's going to say, okay, I have these 3 shelves to create and they have this information. Okay. But this is only applied to this one shelf. So I could do the same thing. I could click on this shelf and I could add that same information and change these properties. Or what I could do is I could say, this is going to be the default for my definition, for my rack definition, the my rack definition. And I could do that very simply by right-clicking on the instance I have changed. And I could say, update my rack property defaults from this. So this is updating my object definition. And I could see that this unbolds, no, meaning that it's now a default. And I could click on all of my other racks and see that it is the same values now. So it has applied that default property values across all of the other racks that are from that definition. Run. I can see that I have shelves created, which is great. But I have yet to have entities. So we actually need to do one other quick thing, and that is give an initial quantity. So I'm just going to say 9 because I have 9 spaces in my rack. And again, I want to update. So all of my racks are going to have initial quality of 9. But that is information you could also store in a data table. So maybe you have your data table specifying, we have this stock at these shelves, and you could hook that up to these properties and say, I want this thing to start, this entity to start at this shelf. All right, so now if I run, I see my entities on my shelves. Great. And then one other thing I wanted to show is in your shelf table. So again, the power of having this be in a data table or use that shelf configuration repeat group is that you can have unique values for each of these shelves. So let's say I wanted to change this where I actually wanted my highest shelf to only be able to hold one entity. Right now, everything holds 3 entities. So with your data tables, you can filter on certain items. So you could use that little key up here and you could select certain things. Or you can use this auto filter row, which is really nifty and lets you filter on different kind of criteria. So here we're going to select ends with, and I'm going to say I want all of my shelves to end with 3 because my shelf IDs, the third one is the highest shelf. So here I have all of my 3s, and I could change this to say I only want to hold 1. Oh, since this is still bound, I would need to remove the binding. So I'm going to remove the binding really quickly because if I have the binding, it's going to want to stay true to that data file that it is bound to. So if I remove the binding, now I can edit this and I can say 1. And again, our data tables are copy and paste friendly, so I can select all of these cells very quickly and paste them in. And I'm just showing this, but instead of doing this, you could have another data file with maybe a different configuration of shelves. So you could test different shelf configurations and you could import different files. So you can kind of have an experiment where you're changing your files. Okay, so I made all of this a capacity of 1, and I want to say my lowest shelf can have a capacity of 5. Okay, great. So now I can unfilter and I can see that we have unique values for each of my shelves, and I can go back to my facility, I can run, and I can see that now my shelves are doing different things. And one other thing I wanted to show, so again, so now our shelves are data driven. They're using the information from our shelf data table to create the shelves. But I also want to have my entities routed with using the data tables. So as the entities leave the rack, they, one, need to request a ride from the forklift. So we're going to need to change that on our output node. So that's where we say, does it need a transporter? And we're going to say always. And we're going to say we need a forklift. So that was another one of our objects we had data generated. So here's our forklift. And I want to say, instead of continuing, we're going to select a location from a list. So our data tables can actually also be lists. So if I go back to the data table, the packing station is where I want the entity to go after it's taken off of the rack. And in my packing station data table, I have this column for input node. So here I'm saying these are my input locations to my packing stations. I could use this column as my node list, which is what we're going to do. So I can go back to my facility and we're going to do packing station table dot input node. And oops, I did not type node. Perfect. Okay, so now when I select from the list, I'm going to look at that data table column for the nodes, and we're going to select something from there. And just for this example, I'm going to choose random, but this is a location where maybe you could think about, which packing station do I want to go to? Am I trying to match up within another order? Am I trying to, am I picking different things to put together for an order? So maybe I need to check for that. Or maybe I just want to go to a packing station that's, available, least busy, something like that. So we're just going to go with random. And again, I've only set this for this one rack, and this is the node associated with that rack. So if I go to this node, it doesn't have any of that information, but I can do that little trick to right click and say update rack property defaults from this. And it's unbolded now. We can click here and see that this is also updated to say I need a forklift. We're going to select from a list and so on. All right, choose the speed and let that run, and we're going to see that our forklift is going to go and pick things up and drop things off at one of our packing stations. I'm gonna skip through a couple things, but there are a couple other enhancements you could do this model to, also have it be data driven. So, you could select a server and you could change its processing time, and that processing time could be read in from your data table. So maybe your data table has different processing times for each packing station. Or for our worker and our forklift, we could change the population number. So if I just pause this for a second and we go back to data, we have our resource table and we have this column here for population. So we could hook up this column to our worker and our forklift, and we could say, we would like you to use, oops, let's see. Oh, it needs to be an integer. Okay. Can't have not a whole forklift. Okay, so you can say use this table reference as the population. So if I hit run now, oops, it did not know which row to use, and that is because this needs to be a key. Okay, so now I should have multiple, oh, nope, we're still only doing one. Okay, well, that is something you could set up. I'm not sure why, oh, they're on top of each other. Okay, yeah. So we should see 3 forklifts as we run this model. And so that could be something you could, again, consider making multiple files. So if you had a bunch of different vehicles or workers and you had population specified in a table, we could see changing that file and being like, okay, maybe I want to try different populations. So again, you could change the file to change the population number instead of making that like a reference property and changing that in an experiment. Okay, so we see our 3 forklifts now moving around. Awesome. All right, a few other things I wanted to get to before we get to the questions, and that is showing some of the other things you might think about doing with your data tables. So for example, we now have, these shelves individually listed out. So if you wanted to collect information on each of the shelves, you can consider doing that. Like you could consider adding more columns, you can consider adding a state column and, maybe counting something. I mean, the shelves are going to have information that they automatically collect, but if you wanted to collect your own statistics, you could think about adding that in here because now we have this shelf detailed column or shelf detailed data table. Similarly, for the rack, you could think about collecting how much weight is being stored on a rack. So we could consider adding in a state column and saying, this is a state variable, sorry, so this is a state variable. Each one of these cells is a variable that corresponds to this row. And you can see that's grayed out and I can't type anything in there. And that's because this is only assignable during the run. So you're going to update this value as your model runs. So the state column could be the weight. So we could collect the weight as entities are put onto a shelf. We could add the weight, or as they're removed from the shelf, we could subtract the weight from this state variable. And then we could also think about auto-creating elements. So as I said before, you can create the objects, but you can also auto-create elements. So you'll see we have our element column properties up here. So let's say we wanted to collect a state statistic. So over here, we have the option to reference or to create. And if we create, we can set initial property values. So if I open this, I could say, what is the state that I want to collect? The state variable name, and it could be that state column we just created. So it could be rack table dot real state 1. So it's going to look at the state variable that is in the state column, which is really cool. So why are we doing this? Well, maybe we're using that state to collect the weight of the rack, and maybe we want a state statistic because we want to be able to see that what racks weight over the span of the run. So the state statistic is going to be a time-dependent statistic. You could see how it changes throughout the run. Okay, so I set this up in a different model that I would like to show. So I did that same thing here. I have my weight, I have my state statistic. And then you could use the state statistics. These state statistics could be collected in a log, so you could use logging here. And then you can use that log to feed into a dashboard. So again, if we go to results, I created this dashboard that's looking at the state statistic for each rack. So yes, there are a lot of them. You might think about bucketing them differently if you wanted to look at certain things. But here I can just select a couple different racks and kind of see how their weight has changed over the run. So that's a useful thing. And if you want some more information on dashboards, that was actually one of our first Simio Solution Series presentations. You could go back and check out that video. So that's another thing you might consider doing with your data tables. And then the last thing I wanted to talk about was if you wanted to experiment with your data bindings. So as I first showed, we imported our data, we created this data binding or this data connector, our CSV connector. And if you go to data connectors, you kind of get a summary of, where is this data connector used? What are the tables hooked up to it? What is this import folder? And we could create more data importers. But what is actually, I think, a little bit easier is to create different configurations for each data importer. So here I could add a configuration. Or just leave it defaultly named. And this one says, I could change the folder that I'm looking at. So maybe instead of, my layout 1 folder, I want to look at my data for my layout 2. So I could say look at layout 2, and if the files were named differently, I could specify the file names. They happen to be named the same. So I could hook up, which file goes to which table and all of that. So jumping to, I hooked that up previously. So here I have different layouts. I have, maybe I want to experiment with, different aisle numbers, or sorry, different row and column numbers for how my racks are laid out. So this was our general layout that we started with, but so my layout 2 changes that formation. So we're gonna, change from default to layout 2, and I can just select that configuration and say import all of the matching bindings, and it's going to say I imported new information for these tables, and I'll say okay, and I can go to my facility and I can see that now I have this kind of longer layout for my racks. And so I could experiment, maybe keeping track of how much distance my forklifts or my workers are covering if I have a different layout. So there's something else I did similarly. So I have these configurations. You can create an experiment, and you can actually select these configurations as like a control for your experiment. So you could say, I want to do default 1, and maybe I want to add, sorry, let's add something in here. We're just going to add a property. Okay, so you have your reference properties that you're maybe experimenting with, and then maybe as you're experimenting with your different population sizes, your different workers, different work schedules, so on, you also have that CSV configuration that you could experiment with. So maybe you want, 6 workers, and then you want to try that with the default layout, or 6 workers with the layout 2, and so on. And this also works with OpQuest, so you can use optimization and kind of, change your data importer configurations, and it'll import all of your new data tables, and it could, change the objects that are being created, or just change, the information that the objects are using. I think that is about everything I wanted to show. So I think we could move on to FAQs now, or sorry, our questions section.
Perfect. Thank you, Liz. So let me answer the first question that came up a couple times. There were a few folks that asked that this session is being recorded because they missed the beginning. So just to address that, yes, indeed, the session is being recorded. It will be available on simio.com in short order here. So look for it probably by the middle of tomorrow. It might get on quicker, but it will be out there pretty quickly. So anyone that missed the beginning or wants to go back and watch, it'll be on simio.com. All right, so that was my easy question to answer. So let me throw the hard ones at you, Liz. And actually, we had, just for future purposes, for anyone that's actually attending today's webcast or watching this recorded in the future, we did have a couple questions that came in prior for someone that didn't know if we were going to do question and answer session during the actual the topic today. So they sent a couple questions in prior. So first question, is it possible to use any data-driven solutions with the Simio API?
And that's something that we didn't show today. It is possible. I actually would recommend going to some of our other API resources. So we do have our API reference guide that comes with our installation. So in your programs folder, wherever Simio was installed, you can see our API reference guide. And in there are pages on a few different methods. I believe it's something about creating objects or intelligent creating objects. and you can find the methods to do that. So you could use the data and the API to create the objects for your model. And you could also check out for API, I highly recommend the forum. We have a lot of users talking about the API on the forum. There's its own forum section there. So if you're not part of our Simio Insiders forum, I recommend that. And again, you can find the information to sign up if you're not yet a forum member on our website. And then third, I recommend our Simio GitHub. So we do have a GitHub where we do post some API examples. So you can take a look there. I don't believe API is slotted for any of our future presentations as of yet, but is something we could consider doing in the future. But yeah, something we just didn't cover here, but it is possible.
All right, perfect. Thank you. Next question. How do I move or change a data created object or link?
That's a great question. Okay, so are creating your objects with data. You can slide them around, you can move them. So as I'm here, you can see I'm moving this around. And I actually wanted to show this. So I have my rack table and I'm going to undock this and split screen it here so we can see. So this should be rack 202 and you can see as I slide it around, oops, I could get a handle on it. As I slide it around, it should have updated. Ooh. So it would update, let's see, I think it's because okay. So you can unbind them. You can always unbind your data tables and you can move things. I'm not sure why it's not doing it right now, but typically it should update. Am I grabbing the right rack? Rack 202. Oh, that's why. We're looking at the wrong rack. Okay, so rack 1, okay, 202 should be over here. All right. Rack 202, as I move it around, or make it very large, as I move rack 202 around, it should update its X and Z locations in the table. And it would do that if I had left my binding there as well. So you can slide your things around after you create them with your data. And it's nice that Simio is keeping track of that for you. But as soon as you import from your external file, it is going to replace whatever data was in your external file. So it'll go back to the original X and Z coordinates I had it there. If you were moving things around and you wanted to make sure that the next time you import your data, that they stay where you moved them, I would recommend exporting your data table. So again, it's you can actually export really simply. So you could just save to CSV, and then next time you go to import, you would change to import to that file you had saved off. With the paths, paths are a little bit more specific because you have specified a starting and ending location for your path. And you can't add vertices and drag those as well. You could move the nodes, but you couldn't drag and add vertices to the path. If you wanted to add vertices, you would have to add a table to specify your vertices or add information to your data table to specify vertices for your path. So paths are a little bit special in that way.
Perfect. Perfect. All right. Next question. So first of all, too, I love the giant rack. All the
Yeah.
other racks look very small. Is it possible to bind the model to SharePoint Online Excel files using a URL?
Oh boy. So I think that gets into a little bit of our web API data connector, which is not my strongest suit. So I might recommend emailing into us and we can get you more information on that. I think it might be possible, but it's not, we don't see that commonly done today. I don't have a lot of experience with that, but we could maybe make something work.
Okay. All right. So the person that posed that question, if you want, my email address, I posted at the beginning, but I'll put it up on the screen again here, and you can email me, and I can pass that along. Or actually, I'll post it right in the chat, my email address, so that you can reach out directly to me. Next question, and I know we still have about 10 minutes, so I hope that you don't mind keep going, Liz.
Oh, yeah.
All right. So a modeler would need an accurate blueprint of a warehouse to assign the coordinates of the object, correct?
Again, this kind of goes back into the data collection phase of your project. It's however you want to lay out your objects. In this case, I made up coordinates. So you could kind of just data generate some coordinates, maybe using Python. You could just have some kind of like values to know like how spaced out you think things are to get a best estimate. Or if you do have a blueprint and you do have those coordinates readily available to you in data form, great, definitely use those. Or if you wanted to have kind of Simio is you're building in scale. So if you wanted to import your blueprint, if you just had like your file, your image, your layout, you could import it into Simio, and then you could kind of place a few objects, get a rough estimate as to where coordinates are, and the objects are saving their location. So you could then save a file from Simio and say, hey, okay, I used Simio. I kind of have my rough estimate as to where objects are on my layout because I didn't have that before. And now I could re-import that into other locations as I need it. So this is like my layout data now. I've created it with Simio. And if you want to get a better idea of what I was describing there, it might be a good idea to check out the SimioSync presentation I referenced in the beginning of this video. I talk about saving your coordinates of your existing objects in that video. So it could be a good resource. But
Okay.
yes, you typically you do need to know your layout information.
Okay, and you may have just addressed this, but the follow-up to that question, how can I assign the coordinates if I do not have them in the data?
Yeah. So you're just gonna kind of need to get a best estimate as to like how spaced out you think things are. In this case, I made up my layout, but I made it up using Python. So I said, I have an idea of how many racks I have in this row, and then I know how spaced out and how large they are. So I could kind of just calculate, the point for this rack is this location, and then add, another rack and so on. Or like I said, you could kind of import your layout into Simio. It is drawing to scale. So you would have your layout to scale and you could place a few points, a few nodes, a few servers, whatever, and get an idea of where those coordinates might be, and then kind of extrapolate from that.
Okay, all right. I think we have time. We have two more questions up here, and let me get to these two. Actually, more are popping in, but we'll get to these two at least. So another binding question: is it possible to bind the Simio model to MES for real-time synchronization with the physical system?
Yes, it is. It is definitely possible. I think we kind of briefly showed. So if I go back to data, I'm gonna re-put this in here so we can see better. You can see that one of our options here is you have a MES data importer option. So you can hook up to that and you can import in real time. And you do have other options for like your bindings as far as like how frequently you want your data to change and be imported in and updated. So you have options there.
All right, great. What is the best way to set link selection weights through data?
Sure. Let's talk about that. So actually, let me turn my links back on so we can see that. So here I have my links. My arrows and my nodes so we can take a look at this again. So if you wanted to change your link selection weight, and you're doing a data-driven or a data-generated approach, the selection weight is a property. So what you could do is you could go into your data table where you have your paths, and you could add just another column for this information. So you could just say it's an expression. And so this could be my link weight. And you could type in anything here, and it could just be, at this path, I want to use this link weight. Oh, my data bindings preventing me from typing. So yeah, you could write in any expression. So you could say, is this a model entity, or making sure it has a specific variable, and then you would do that same thing we did before, where I have this now in my data table, and I want to hook it up for my objects to use it. So then you could, say selection weight, reference my paths link weight. And again, you would need a custom object so that you could say this is the default. This is the new default for all of the paths I create. I want them all to use this table reference. So that's one way you could kind of hook that up and use the link weights in your data tables.
Okay. One more question here, and this one I know it's a little bit of a longer answer. So with about 4 minutes left, I'll pose the question if you want to address it to the best of your ability in the next three and a half minutes now as I'm talking. How would you approach modeling each shelf have? No, no. How would you approach each modeling? Let me try it one more time. How would you approach modeling each shelf having 5 storage locations and storing entities in specific locations on the shelf?
Okay, so we have a shelf and we have different storage on each shelf. Okay.
Storage locations, yeah.
Yeah, storage locations on each shelf. All right. Um, yeah, that's into a little bit of trickiness with the shelf and the rack object itself. So the rack is a special object. Again, it comes from our extras library, and a lot of the objects in our extras library are composite objects. So they're made up of multiple objects within each other. So in this case, the rack is the object, but the shelf is actually a entity object within the rack. Um, so you would probably need to go into the shelf definition and say that you are going to have different storage locations in the shelf or on the shelf, and say like so instead of just storing into one place on the shelf, you have 5 options. So it would be more at the shelf definition level, I think, than anything. Or there's probably other ways to go about this. If you wanted to say, I still want to put them all onto this shelf, but maybe you want to break it down at the top level. So you could think about instead, maybe expanding your shelf data and saying, I have shelf 1 and I have storage location 1, 2, 3, 4, 5. Yeah, that's a little bit of a tricky problem. I think I might have to think about it more if you didn't want to have to change the object definition. Um, if whoever asked that would like to chat about it more, I would recommend emailing into Dan or into support, and we could brainstorm more on that.
Yeah, so what I just did is I actually just posted my email address in the chat box for all to see. So if anyone does have a question, or if that question you want to further expand on it, go ahead and email me and I'll pass it along to the appropriate person. So we are running up against the end of time here. I think we've addressed most of the questions in the chat box. If there are any additional questions, my email address is now out there. You can feel free to reach out to me. Otherwise, we will go ahead and wrap up. We have our next session 2 weeks from now on Thursday, July the, what day am I looking at? Thursday, July, no, Thursday, June 16th. Jeez, Thursday, June 16th, our next session. All right. Thank you, Liz. Great job. Anyone has any questions, feel free to reach out and email. Otherwise, we'll wrap here and we'll see everyone again in 2 weeks. Goodbye.
Sounds good. Thanks, everybody.